Cool. Hi, everyone. I'm Anuraj. I'm a software engineer at ShareChat, and um yeah, I work in platform team. And recently, not recently, but we are using Kafka for a long time now. And recently, we have migrated a lot of our workload last year from some of the cloud native queues to Kafka. And there has been a journey, like we have like migrated GBs of workload uh, into Kafka. More specifically, we're using Redpanda. That's a Kafka protocol compliant streaming system. And there has been a lot of challenges and learnings that we have gone through the entire journey. And I would be sharing things around that. It would be random learnings. Just try to, if you have any questions around, just raise your hand and I'll try to summarize that thing. So, okay, so cool. I'll start with the first one. So let's start with a very basic one, like when you use any Kafka client for producers or consumers, you get to configure a lot of things, right? But usually, a lot of people usually start with default. Your clients, like for example, in Golang, we work with Golang a lot in ShareChat, and then a lot of things would be set into defaults, and people would just go with that. But the first slide would be just don't always rely on defaults. This is mainly in context with higher scale, or maybe like if you have use cases varying in scale, like some use cases very low scale, some use cases require high accuracy, high how do you say, you don't want to lose any data. Some use cases where it's fine to lose data, but you don't want to stress your system a lot. So there would be mix of systems, and then accordingly, how do you configure the systems and how do you use various properties. So on the side of batching configs, like you get to configure your buffer bytes, buffer count, or linger ms. Basically, when you produce to a Kafka, when you put a request, you do get to buffer some of the requests, because see, as his previous speaker also conveyed I mean, a thing that they started very small files, right? That small number, and then in Kafka you put smaller messages only. So in a streaming system, you would put too many number of messages but smaller number of messages. So if you recall the previous session, smaller number of messages and too high number of requests can overwhelm any system. So what you need here is that you should, if you have higher number of messages going through your system, you should actually batch those messages and convert them into a single bigger message. And then single bigger message should go to a request should go to Kafka server. Now by default, it may be that your Kafka client is providing a linger or something of 0 second. Say that means that as soon as the message is you call a method to send the message to Kafka, it would immediately go to Kafka, and it would immediately convert a request, say a network request to Kafka, and it would immediately go. And if you have say 30,000 or 50,000 or 100K messages, or that many number of requests translating to network requests and going to the server, that would create too many connections and too many requests at the Kafka server to handle. And that would definitely, you can solve it with say scale ups or something, but that's not always efficient. You do want to handle many messages with as small workload as possible to optimize the cost. Okay, first I would like to understand, maybe I started too early. How many of you are familiar with Kafka and Kafka protocol? Okay, good. Most of you are, so I won't cover much on the Kafka basics or something. Basically, Kafka is a streaming platform. Like you have a couple of brokers deployed, or maybe on VMs or Kubernetes. You have producer applications, you have consumer applications, provides async communication between both of these. Your producers produce to your brokers buffer the data, and then your consumers can consume at their speeds. Okay, cool. So I covered about the batching configs. You should batch according to your workload. If you think that your latency is your workload is highly critical about latency. For example, if you want to immediately consume, say you have very real time. For example, you're working on some fraud detection or something, and you want that message to be there very quickly. And if you put a linger of say 5 seconds or something, then definitely your five messages can get delayed at least 5 seconds or something. Right? So you don't want, you have to be very cautious about these things. Secondly, you also have to be very cautious about the producer acknowledgements. So basically, your producer brokers for reliability purposes provides various kind of acknowledgements. Like your producers can acknowledge message when the message is written to the producer and it has been replicated as well. So Kafka would provide you that reliability. It's sitting in between to provide you the reliability that, okay, if I got the message, I will hold it durability. That, okay, your message, if I have received it, I have confirmed it, I'll make sure that it stays in the system, it is not lost. But but you can still tune it. For example, when your producer sends a message, and if you want that, okay, Kafka should acknowledge me only when it is durably stored. I mean, when it is also written to the replica of the brokers, then only you acknowledge it to me, so that I am pretty sure that, okay, the message is written into the Kafka brokers, and even if some of the machine of the Kafka server dies, my message is still safe. So you can go do that as well. But if you have, say, a higher scale workload, say you're logging something, and then you are fine with losing some data, but you want the system to be very performant, in that cases, you can still go with, say, okay, if one of the broker has acknowledged that, okay, I have written, I'll write to my replicas, but let me give you the acknowledgement that, okay, you can go ahead. That is a lower latency task, but your producer is blocked for a very small time. Your produce request is blocked for a very small time, and then you get the acknowledgement very fast. So again, depending on use case, you can tune that as well. Sorry, come again. So for example, if you have some financial data or something, you don't want to lose that. For example, you have some transaction record going into your system. Now, definitely you don't want to lose that, even if one of your broker machine die. For example, if it's a 9-node cluster, and for some reason one of the zone goes down, you are, say, on AWS or GCP or somewhere, and suddenly one of the zone itself goes down. Yeah, so I'm coming to that. So for example, if 3 of your machine goes down and remaining machines are there, but say if you are using producer acknowledgement of only one, say whenever one of the leader broker acknowledges message, and I'm fine with, okay, I have written the message successfully, then what happens is that as soon as, say, for example, your message is written to the broker, and that at the same point of time the broker machine dies, then it didn't get the chance to replicate the message to the, yeah, and in that case your information is lost. Whereas if you get the acknowledgement, say, okay, give me the thumbs up if you have returned to the replica server as well, then you give me the thumbs up. Then what happens in that case? If it has returned to the leader partition, whatever broker is handling that leader partition, and then after that it has also written to the replica, then only it will acknowledge. If the acknowledge is not coming to your service, then you already know that the message failed and you can retry. Cool. Cool. Let me move to the third point. Maybe this is mostly in context of the other 2 points are very much applicable to any context, Java, Golang, or whatever client you are using. But the third point would be more in context of FriendsGo, or maybe in other contexts as well. But basically, you should also tune your partitioner. In FriendsGo, by default, it uses evolved version of sticky partitioner. It's a uniform bytes partitioner. Basically, it also provides you a config that you can pin the number of connections that you are sending to brokers. So basically, when you are sending the messages to your brokers, they keep on switching partitions. For example, you can create, say, 100 or more partitions, but your brokers are, say, 12 or something only, right? Then these partitions are divided across your brokers, and then the messages are sent. You do want to distribute your messages across multiple partitions so that your workload is divided across brokers and it is not hotspotting any particular broker. Now, what happens is that in case of when your partitioner switches these partitions, it can switch the connections to the brokers. Now, you don't want to make these switches very frequent, because then it would make the Kafka server to handle too many connections, too many quick open and close connections. So you should also tune your partitioner so that it holds the connection for a significant amount of time, say a 1 second or 2 second, whatever your workload is like. And then accordingly, you should be aware about your workload. Cool. Apart from that, there is a second point, that is retries for successful delivery. Basically, what happens is that, be it Kafka, Redpanda, or any other system, for example, if something goes wrong in production, some node dies or something like that, what would happen is that now Kafka behind the scene, for every partition, it would hold replicas as well. And whenever a node dies and which contains some leader partitions, in any distributed system which is maintaining consensus, it would hold a leader action. What it would do is, from the replicas that are available, it would try to nominate the remaining replica, one of the remaining replica, as the leader. Now, this election process, meanwhile, the election process, since the machine which contained the leader already died, so now whatever messages that are going to the system, they cannot go to anywhere. Like, they do not have a leader where they will go. So meanwhile, the time when the new leader is elected, that particular point of time, you will get some produce errors. And what that error would say, generally the error would say no leaders or followers are available. And that means you should retry. Now the election will complete. You will have a new leader for sure. But meanwhile, that particular point of time, if you do not retry, then your messages will be lost, or you either have to handle it somewhere, somehow. But if you have, say, what we have observed in production, say if you have 3 or 5 or 7 retries according to your scale, that works fine. In case of Redpanda, the system that we use, it continuously keep on optimizing your partition leadership to spread it across the brokers so that you don't have a skew on workload. So basically, retries on producers takes care of these small nuances in production. Cool. Apart from that, I have been spoken about these hotspotting issues, but let me clarify here where all you can get into hotspotting issues. We got into some hotspotting issues in production, but basically, if your producers are kind of somehow if you have very less partitions or something than your brokers and you are putting too much data, then it could happen that you're sending your messages to only few brokers. And if your partitions are not properly distributed, then what happened? What would happen, that if your particular topic is receiving too much volume of data, and if you're sending it to only few brokers, then you're not utilizing your complete capacity of your Kafka service efficiently. Secondly, second point is a very that kind of use case which people, it's not very intuitive. People generally get into this problem is what happens is that most of the Kafka client at the consumer end would provide you auto commits as default. But some people will, because of their use case or something, what they would start doing is they will start doing manual commits. Now, the problem with manual commits is, if you commit every message and if your scale is higher, then you are issuing too many commit requests. And now what would happen is that also, for every topic or something, Kafka actually behind the scene maintains a specific dedicated topic, say consumer offsets. If you look into the number of topics, your system topics, you'll see __ consumer offsets or something, a topic like this. And one of the partition of that particular topic will be responsible for your topic offsets. Now, if any of your single, say, consumer group is making too many offset commit requests or something, you could, first of all, you could overwhelm your brokers for issuing too many requests. Secondly, you could overwhelm one of the partitions. So basically, one of the broker specifically in your Kafka system. And that would, be a little challenging, because you have given same amount of resources to all of your brokers and the requests are not getting distributed properly. Let me know if anyone has any confusion in any of the points. Okay, just raise your hand in between. Hot sorting. Yeah. So basically, the point which I've showed in this slide is basically, for example, take one of the use case, say you have 12 brokers and you have configured. Hmm. Hmm. And then get your question, sir. Hmm. Huh. Huh. No, no. So in case of producers, so, okay. So what I was mentioning is that, for example, if you have only three partitions or something, okay, and your broker count is more, and if you have a higher scale on your on that particular topic, now if you have say three partition and 12 brokers, those three partition will choose any three brokers for their leader partition. Okay. Now if you have no, no, I mean that's not a theoretical. There is no theoretical challenge in designing like that. But ideally, it is like that. It's a best practice, obviously, that you put if your topic scale is very significantly higher, you should put more partition than your brokers, or maybe multiples of your brokers. I'll come to that point in a slide as well. Yeah. Cool. Okay, okay. So this is also something that people do miss out in production very frequently. What would happen is that if you're producing to multiple topics or something, then what would usually it's very intuitive that you would create multiple Kafka clients. That is actually a really bad idea because what would happen is that Kafka clients behind the scene manage their own connections to the brokers. Now, say if you are handling three topics, if you're producing two, three topics, or say consuming from a topic now these are, and if you create four Kafka clients in production, then each of these Kafka client will internally hold their connection to Kafka server or something. Now, if your scale is higher or if you're switching partitions also too quickly, then the number of connection that your single application, and if your application pods are also higher, say 100 and hundreds or something, then even your single application can go around creating thousands of connections on Kafka. And that would be too bad for your Kafka server. So ideally, it is good that whatever number of topics you have, if you are connecting the same Kafka server, you create only one Kafka client. You can do both produce and consume to any number of topics with the single Kafka client. Okay. No, sir. Which system you're talking about? Which particular, if you like to mention? Uh-huh. Okay. So the topics belong to the same Kafka cluster or a different Kafka cluster? Definitely, if it's a different Kafka cluster, then definitely you have to separate out the client because you provide the seed where the Kafka client should connect to. That would definitely differ. But usually, if you have, say, topics in the same Kafka cluster, then you should create only one client for that, but those number of topics. Cool. This is one of the decision that everyone has to take while writing in production. Uh, at say at lower scale, higher scale, how would you decide the number of partition? I'll come to your question as well, sir. So now one warning is such in the very beginning, a wrong number of partitions, what we have observed in production is can affect all three. It can affect your producers, it can affect your consumers, and it can affect the Kafka server as well. So the first example, for example, if I take, say if I have higher number of brokers and say I start with a very small throughput, say in kbps or something, and I design and I start with very few partitions, say for example one or three or five only, and then suddenly what would happen is that people won't realize, but suddenly the traffic increased on their service, or they have scaled up some experiment or something like that, and throughput suddenly increased to say MBs or something, MBs per second or something. And then what would happen is that if some of the brokers because your partitions are very less than your brokers, and then some of the brokers start getting too much request, too much data, then this queue is there in the system, and then you are not efficiently utilizing your broker machines. So basically, as a rule of thumb, if you have significant amount of traffic, then basically you can go with a number of partitions in multiples of your brokers. Maybe equal to your brokers, start with the partitions equal to your brokers. For example, if you have 12, start with 12 partitions. If you have significant throughput, then double up, 24 and then 36 or something like that. Or you can use a this series, you can check about it, highly composite number. Basically, these are the numbers which have multiples greater than any number below that particular number. So the series goes as like 24, 36, something like this. So you can use this particular series results. It will provide you good multiples for your broker counts. Because in production, you keep on changing brokers as well along with scale. So it is generally advisable in case of, like, if you see Flink documents, documentation or things, they will actually recommend highly composite numbers for your partition counts. Cool. Apart from that, there is one important thing which definitely partition count matters a lot, is how frequently your consumers are able to consume. So definitely in production, you will have some SLA around your consumers on the E2E latency. When you produce something and how quickly it is consumed at your consumer end. If you want very real-time consumption, you don't want any lag to accumulate in your Kafka server when you're consuming, then definitely you should think about your number of partitions according to the number of consumers that you will need. Every consumer, you'll know that how much processing time it will take, and how much messages you can consume per second. For example, if your consumer is able to consume, say, 200 messages per second, and at peak time you get, say, 1,000 messages per second, then you definitely know that at peak time you need 5 consumers to, or maybe 6 consumers to keep up some buffer. Then you should have definitely 6 partitions, right? So that your consumers, when they scale up at the peak time, they will have enough partitions to consume from. And in fact, not only that, you should also account for festive season times. This is one of the things that most of the people would miss, but it is important. In festive season times, when your peaks are even higher, then at that particular point of time, you might want to scale up more consumers, but you don't have enough partitions. And then you have to quickly at that particular point of time go around in production and do the scaling and everything. Cool. Apart from that, there is one important warning as well, that you should not actually create too many partitions as well. It is very intuitive that people would go say, okay, just create, let's for every topic, whatever the scale is, just create 500 partitions, and then we should be good. That is actually not true. If say, for example, if you have a Kafka cluster, you have 1,000 topics, and for every topic you create 500 partitions. That's too many partitions. That is too much metadata for your Kafka servers to handle. Obviously, you can scale up the system. You can put, say, 24 vCPU machines and 50 machines or something. It would handle any kind of workload, but that would cost you a lot. So if you want a cost-efficient engineering, you should have taken care of not creating too much overhead for your work brokers as well. Apart from that, there's a tip for producers, basically. So as a rule of thumb, wherever possible, you should use async produce. So be it Java client or be it Golang client, both of these will provide async produce for your systems. Basically, what async produce would do is you call the send method or produce method. It would take your message and it will allow you to add a callback. It will say, okay, I'll take care of this particular message in a separate thread. You continue with your main thread, and whenever I'm done with producing that particular message, I'll give you a callback. Maybe it's a success callback or maybe it's a failure callback. You can take care of that separately. This will not block your main thread. So for example, if you're in a REST service and you're handling, say, one of the call in one of the thread, and say if that particular thread is waiting for, say, if you have a linger time of, say, 1 second or something, and if your thread is still waiting, then definitely your number of requests that your particular REST service will be able to serve will definitely drastically reduce. So you don't want that in production. So wherever possible, you should use async produce. Obviously, There are use cases for sync produce as well, where you want higher guarantee and you want to wait for the message. Your message is very critical to be sent. Then in that cases, definitely you should use sync produce as well. Apart from that, there is a method in Golang specifically in Franz-Go client, which is called try produce. It's a fail fast method. So if I specify a little about fail fast, basically, whenever some error happens in the system, instead of retrying, you just simply fail fast and take the back channel, maybe some failover or something. This is generally advisable in the systems where you have too much workload to process, too higher scale, and any retries can actually overwhelm your system more, or maybe put your system into a worse state. So if if your system is already too much, how do I say, handling too many things, and if you put retries also because of some failures, then your system is going to be more overwhelmed. So basically, if you have a fail fast method available in your client, you should use that. Apart from that, graceful shutdowns. What would happen is that people would usually ignore that. Say, for example, if you're in a consumer client and then because of some system, if you have deployment on say Kubernetes or something, you will keep on receiving sick time. Your pods will keep on killing themselves and respawning themselves. Now, what would happen if you don't put full shutdown hook and you don't handle those signals? And let's say you have already consumed some messages and you have already committed. Let's say you are using at most one kind of processing, and you're already committing the messages, and you have consumed some messages and your pod killed. Then what would happen is that the messages which are there in the memory, those are lost. You are not processed those messages and your pod already died. So what you should do is system signal give you some time. So you should stop consuming newer messages. You should process whatever is left in your memory, commit them quickly. Same goes for producer applications as well. Whatever is there in your buffer, you should stop your producer client. Whatever is there in the buffer, just produce it immediately, or maybe wait for your linger time and then throw away your pod. Apart from that, tiered storage, this is still not there in the open source Kafka version. There is a PR, there is some work going around on tiered storage. Basically, what would happen is currently open source Kafka client will hold everything in SSDs, but tiered storage is something some of the products like Confluent or Redpanda they are providing. So basically, from SSDs they can back up your messages into tiered storage as well. So in SSDs you can keep say 5 hours of data or something. And then remaining data, for example, if you have 7 days of retention on your data, after 5 hours, the data will automatically go to object storage, which is much more cheaper and keeps your costs in control. I'll quickly go through the slides because I'm on lesson time. But maybe if you have any questions, meanwhile, just raise your hand. Yeah, please. Of course, sir. So, for example, if meanwhile, say some partition leadership is changing or something like that, your produce request will definitely has to retry. And any time a retry will happen, the end-to-end latency will definitely be impacted. And similar goes for the consumer client server, because consumer client by default will consume only from the leader partitions. If consume fetch request will go, it won't find the leader partition. It has to retry the fetch. So definitely E2E latency will definitely be affected if your if your system is going through rebalances. Yeah. Yeah. So mostly, sir, it is like you should know your workload. You should know your traffic pattern. You should know your peaks. Accordingly, you should decide. Obviously, there are changes in the system over time to time. Your traffic pattern might change. Your broker count might change. All of these things will happen, but you should keep your traffic patterns and your scale in mind while designing these things. All the configuration, in fact, any of the configuration which I have shown you, those are all tunable plugs which would differ use case to use case. Obviously, you can create something. You can create some job or something which keeps on reading your volume or something, like maybe you can get some data from Prometheus, say. You might have observability on your Prometheus for your client side or maybe broker side throughput or something. You can read through a cumulative average of your 24-hour throughput and accordingly say, okay, I've read 500 Mbps or something. Accordingly, I should have this particular change, and you can create some automation job. That's on you. Cool. Apart from that, this in our experience, this is very much important. So what would happen is you get into any particular kind of issues, maybe on client side, maybe on broker side. Usually, whatever Kafka brokers that you are employing, they would expose some matrices, standard matrices. Of you are going through any enterprise solution, they will give you some observability beforehand. But on the client side, people will generally forget. What would happen, like I'm sure most of you would have Prometheus-based observability around your applications. What would happen? What happens is that Java client or Golang Kafka client, they do provide some hooks and matrices which you can actually use in production to find out what is happening at your pod level. How, for example, some of the metrics which I have mentioned here in the producer side, you should actually look for your compression ratios, how your compression and things are going through. What is your bytes produce rate? You can check it through per pod level, across application level. This is the beauty of having client-side matrices. Apart from that, you should also look for, this is a very important metric, batches produced and batch size. So when you're batching the data, you know that you have put in some limits, but how your data, how your pod is handling the things, you should get that particular observability in the Prometheus so that you know actually how many batches are getting produced per second, what is my batch size in terms of number of messages and the size, what is your latency going through the produce request. And similarly for consumers, what is the number of messages that you're coming through, consuming, and what is the commit interval that you're going through, what is the heartbeat. If there is one more important metric that I missed, I think in this, it's the rebalance rate. If you're consuming, for example, getting OM killed or something like out of memory or something, and if you're rebalancing too frequently, that also have a very serious impact on production. You will, like in seconds or minutes only, you will accumulate like millions of legs. That's too bad of a thing for production system. Apart from that, you should always have a metric for connections. Connections are one thing that can really mess up your systems in production. If you're putting too many connections on your Kafka servers or something, then definitely one thing definitely is there that you scale up the systems a lot more, but that's not very cost efficient, and you should avoid that. Cool. Apart from that, I have shared some references. A lot of the points which I have mentioned here actually comes from one of the blog that I have written quite recently. You can go through this particular blog. So evolving event streaming architectures at ShareChat. I've written this last year. So as I mentioned, like last year, we have migrated a lot of workload to Kafka servers. And this blogs goes through the entire journey and the learnings and everything in that particular journey. You can go through this blog, and yeah, you can reach out to me on LinkedIn if you have any feedbacks or something. Cool. Apart from that, I'm open for questions if anyone has any. Yeah. So, sir, what happens is, as of now, Kafka is not auto-scalable. It's a very challenging problem to auto-scale systems which are stateful. So definitely, if your question is around that, okay, my traffic goes down in night to a very low point, but in say evening time or something, it significantly doubles or triples of what it is there in the night time. Then unfortunately, I have to still live with that particular peak time with your stateful systems, be it a Flink job, be it your Kafka servers or something. These are not very auto-scalable system, at least as of now. Maybe in future, if something happens in
Yeah, on daily basis it might be difficult, but there can be a system where for a seasonal basis.
So definitely you can change your broker count, sir. So what you can do is, like, say if you are coming across month end or something where you have more traffic, at that particular point of time you can add more brokers in your system. With Kafka, you can actually scale up and scale down your systems. You should not do it very frequently because that goes through a lot of changes, a lot of data interchange among the brokers, a lot of partition leadership changes and a lot of that. And you will receive a couple of errors and you have to retry for those in producer and consumer client. If you have all that in control, you can do that, but cannot be too frequent. Sorry, come again. Okay, so Confluent Kafka is what would happen is that, ma'am, they internally they would have some bigger Kafka cluster or something, and they would allow multiple neighbors to share those systems. And what would they do is this? For example, they've designed a system for 10 GBs or 10 Gbps or something, and if you are putting say 100 Mbps, even if you turn off your system, turn out your or maybe increase to 200 Mbps or something, they have already have bigger space for allowing you or apart from you many other clients as well. So what model they would go through is that they'll maybe charge you based on throughput instead of the compute resources that they are actually spending on. They will actually instead charge you on throughput. That is something that most of your cloud vendors will also do. So for example, say Google PubSub or Amazon SQS or something, they will charge you on throughput. That is actually a charge that is something with our experience that would how do I say, excite you much in the very beginning when your throughput is very less. Okay, I don't have to deploy that many machines or something that might cost me thousands, but I can maybe because my throughput is in kbps or something only, I can go away with a very small charge. But what would happen is as soon as you go higher, and then you go really quickly, to be honest, that throughput charge will cost you very, very significantly. Cool. Yeah. Any other questions? Yeah. Yeah, sir. So I'll share one production example. So what would happen is that like we had a service which had a very high RPS. Okay. Now it's a Golang service. What would happen is we are using Gin framework. It would create a Go routine for every request that is processing. In case of Java, for example, if you are using Spring or something, it would create a thread for every request that you're processing. Now, say if you're not doing fail fast, and what would happen is that when you call a produce method, it would append the method, append your message into a buffer in your batch, in memory batch. And once it is appended, it would return. Now, take the extent of it that this particular append operation, what it would do is when the batch, when there is a space available in your batch, which is currently being prepared, it would append. But if there is no space available, it will say, okay, let this particular batch go be produced, and then I'll append it to second batch. Now, it would look very simple in this terms, but the small time that it has to wait. Now, if you have a really high RPS on your system and your Golang and your Go routines, if it has to wait for say even say 50 ms or 100 ms time, and since your requests are keep on coming and they will keep on increasing the say if you're done with one of the requests, the go routine gets freed and it can be used for a request. But if it is busy, say for 50 100 ms or something, or maybe for a second, your system has to create new go routines. And we end up into the situation where because we were buffering the data and we were sending, and the send was not that quick as we are getting that particular number of messages, some of the requests got into the state where they found the buffer to be already full and they had to wait till the next buffer. And at that particular point of time, our go routine spiked, and they spiked to thousands. And because of that, our pod started killed because of out of memory. And that's where we realized that we need to fail fast. And what we did is Friends Go client, because of this maybe reason only, they provide a try produce client, which would what it would do is even if it finds buffer to be full, it would just immediately fail. And it will let you handle in your callback what you want to do. If you want to reproduce it, you can do that. If you want to take it through some back channel, maybe through some fallback mechanism or something, you can do that too. So mostly fail fast methods are something is a rule of thumb. You should use them when your system is already overwhelmed. Sorry, come again. I mean, that depends if you want order delivery or something. But anyways, like if you want ordering or something, anyways, in Kafka, you should be having keyed messages and things. That's a separate handling route. Yeah. Anyone, if anything, or yeah, cool. I'll be here only. We can talk. Yeah. Yeah, sure. One is ma'am. Good questions, I think. One sir, I think, got some good questions. Yeah. Thank you.
Thank you so much, Anuraj.